For most of human history, life on Earth felt like a sealed miracle, something that sparked here, in our oceans, under our sun, inside the boundaries of our own planet. But modern science has been chipping away at that idea for decades. And now, one of the most fascinating possibilities is also one of the simplest. What if life didn't start here at all? What if some of the ingredients, or even the earliest seeds, arrived from space, carried by asteroids?
4+ billion years ago, the Earth was pummeled by asteroids in a time called the Late Bombardment.
At first, this idea sounds like science fiction, but it didn't come from filmmakers. It came from chemists, astronomers, and astrobiologists tracking real physical evidence. And what they've discovered over the years has been quietly reshaping how we think about the origin of life. It starts with meteorites, not the big, dramatic extinction-level impacts everyone imagines, but smaller fragments of asteroids that have fallen to Earth and been carefully analyzed in laboratories. Inside many of these space rocks, scientists have found something extraordinary: complex organic molecules, amino acids, the very chemical building blocks used by living systems on our planet. These aren't hypothetical. They're real, measured, verified. Some meteorites contain dozens of different amino acids, including ones not commonly used in Earth life. Others contain nucleobase-like compounds, which are related to the components that build DNA and RNA. In other words, these rocks aren't just carrying minerals. They're carrying the raw chemistry of life. And here's the part that matters. Many of these space organic molecules are not easily formed under Earth-like conditions. They form in cold, low-pressure environments, the kind you find in interstellar space and the early solar system, which means they likely didn't originate on Earth at all. They arrived here. Billions of years ago, during the early formation of our planet, the solar system was a violent place. Earth didn't quietly form and cool down in isolation. It was constantly bombarded by debris, comets, asteroids, rocky fragments left over from planet formation. This period is known as the Late Heavy Bombardment. And during that time, Earth was being showered with material from all over the solar system. Some of those impacts were catastrophic. They reshaped the surface, heated the atmosphere, and could even sterilize entire regions temporarily. But others delivered something much more subtle: carbon, nitrogen, hydrogen, and complex organic chemistry. Asteroids weren't just destroyers. They were delivery vehicles. Now, did they deliver life itself, or just the ingredients for life? This is where the science gets really interesting. There's a hypothesis called panspermia, not the idea that alien civilizations planted life here. That's a popular distorted version, but the idea that life or pre-life chemistry can travel between worlds naturally, via rocks. Under this idea, asteroids and comets act as carriers. They form in one place, incorporate organic molecules, drift through space, then collide with a planet and deposit that material. But wouldn't the impact destroy everything? Not necessarily. Experiments have shown that certain microbes and organic molecules can survive extreme conditions, even high-speed impacts, even short bursts of intense heat, especially if they're shielded inside a rock. Laboratory simulations have subjected microbes to vacuum, radiation, freezing, and impact pressures. Some survive, not forever, but long enough to make the theory physically possible. And not just microbes. Even if no living organisms survive the trip, the chemical molecules do. Many organic compounds are surprisingly resilient. Some can survive atmospheric entry and impact buried within meteorites, protected from the most intense heat. That's important because life doesn't appear all at once. It's a process. It requires a chemical environment rich enough to allow complexity to increase. Asteroids would have provided that environment. They could have enriched Earth's early oceans with carbon compounds, giving early Earth a chemical head start. But there's more. Recent research hasn't just looked at meteorites. Scientists have also studied comets up close using space missions. For example, probes that have analyzed comet dust directly have confirmed the presence of sugar molecules, including ribose, which is a key part of RNA. RNA is central to life as we know it. It's basically a bridge between chemistry and biology. So when scientists find sugars and organic compounds in space, in the exact kinds of objects that bombarded Earth early on, it starts to redraw the origin story. Life may not have been created out of nothing on Earth. It may have been assembled from parts delivered over millions of years, not as a single event, not as one lucky impact, but as a slow accumulation, drop by drop, rock by rock, molecule by molecule. Some scientists go even further. They suggest that not just the ingredients, but early microbial life could have formed elsewhere and arrived here later. Perhaps early Mars, perhaps ancient icy moons, perhaps some long-destroyed body that once orbited the young sun. Under this possibility, Earth didn't create life from scratch. It inherited it, or at least shared the same source as other places. There's no proof of this yet, but it's no longer treated as nonsense. And that's what makes the research surprising. Not that asteroids played a role, but how strong the case for their involvement has become. Another fascinating piece of evidence comes from deep-sea research on Earth. The oldest signs of life we've found aren't from land. They're from ancient ocean environments, possibly near hydrothermal vents, places where heat, minerals, and chemistry mixed under extreme conditions. Now imagine this. If asteroids brought organic molecules to early Earth, they would have rained into oceans, mixed into water, sunk, collected around volcanic areas, concentrated by geological processes. Exactly the kind of environments where life's first self-replicating systems could form. Asteroids could have fed those regions with constant chemical fuel, not just one delivery, but thousands, tens of thousands, over millions of years, each one increasing chemical complexity slightly more than before, until eventually, chemistry crossed a threshold and began behaving like biology. Self-replication, selection, evolution. From that point, the rest is history. Now here's the important part. Even if life didn't originate elsewhere and travel here fully formed, asteroids almost certainly influenced the process. They shaped the chemical environment. They delivered rare compounds. They changed ocean compositions. They triggered environmental changes that forced early life to adapt. In some ways, life isn't purely Earthborn. It's a product of both Earth and space, a collaboration between a planet and the cosmos. And that idea changes how we think about life beyond Earth too. Because if asteroids helped seed life here, then they may be doing the same thing elsewhere. Every solar system likely has its own asteroid belts, comet clouds, and debris fields. Every young planet goes through a bombardment phase. Every rocky world might receive similar deliveries. If the chemistry of life is universal, based on carbon, water, energy, then the process could repeat. Not once, not twice, but potentially thousands or millions of times across the galaxy. Not necessarily intelligent life, but life. Microbes, simple organisms, chemical ecosystems waiting to evolve. Asteroids would not be harbingers of destruction alone. They'd be carriers of possibility. But here's where we need to stay grounded. None of this proves life definitely came from space. It doesn't. Earth still had its own conditions that could produce life. Volcanic activity, geothermal vents, a dynamic atmosphere, and plenty of energy sources. Life could have originated here independently. What the research suggests isn't that Earth couldn't create life. It's that it probably didn't do it alone. Asteroids weren't the creators. They were collaborators. They didn't write the whole story. They delivered some of the alphabet. And Earth wrote the rest. Which, in a way, makes life on this planet feel even more connected to the universe. Not an isolated accident, not a lonely spark, but part of a larger cosmic process where stars, planets, space rocks, and chemistry interact over billions of years to produce living systems. And maybe, somewhere else right now, another young planet is being bombarded by its own asteroids, receiving its own supply of cosmic chemistry, cooking its own life story from the same universal ingredients. And it all started the same way ours might have, not just in the oceans, but in the sky.